Hello, good folks, and welcome to part number 2 of a 6-part series about multimeters. Today, we're going to cover the basics, which is safety, the symbols that you need to be aware of and understand, the ratings, so that you know if your equipment is properly, sized and everything for, what test you're going to be doing, the measurement functions, and then the measurement units. And then we're going to go into what we're getting ready to show you in the next 4 videos, which is demonstrations of how a meter works and how you're actually going to use it on live circuits and stuff. Now, as far as safety goes, first thing that we want to do is we want to look at the equipment or your meter. You want to check the leads out, make sure that they're in good shape. And then before you go ahead and then get into a cabinet or whatever, take your meter to a known circuit. Say like you got a receptacle and it's got 110 volts on it. So take that meter, check that receptacle, after you set it to volts, make sure that your meter is functioning properly. Then after that, you want to be aware of some of the symbols and everything that they use on meters, which is, there's a big triangle, and it looks like a lightning bolt that comes through it. Okay, what that's going to tell you is when you see that, now, I don't know if you can see it right here, but right there, that is telling you the maximum voltages and everything and what its category ratings are for you to be aware of and to not exceed. Because that's when, it's really dangerous when you get, above that. So that's what that symbol's telling you. Another symbol that you want to be aware of, as far as safety goes, is your OL. And typically this will vary with different meters and everything, but if you're equal to or greater than plus or minus 30 volts, or a certain percentage of what you've got it set at or what its capacity is, it's going to give you OL. And that's telling you that, you're over the limit or overloaded. So you need to know what that OL is standing for. And we'll cover that in each one of the different functions, while we're testing it, because actually the OL is telling us different things depending on what function that we're actually testing. And that's it for today on the safety. And I just wanted to cover just the very basics on that. But now symbols, there's several different symbols, and you're going to get a chance to look at my fine artistic ability right here. And we're going to cover them. But you're going to see this symbol right here, the sine wave. That's telling you that it's AC, alternating current. Okay, and so that can be for testing. It'll either have an A underneath of it, or it'll have a V, or it could be, an A to either side of it, or a V. A is telling you that it's amperage, and V is telling you that it's voltage. Because most meters will be able to go ahead and then test out your AC voltage and current. Now, if you see this, let me find my eraser right here, okay. This symbol that's DC. So, that just means that we can check our current and our voltage. So it's also going to be the same thing. It can either have an A or it can have a V. And some meters, might even have an E or an I being for current, just like the A stands for current, and then E standing for voltage, just like the V does. So it really depends on what part of the world and everything that you're in. But that symbol right there is for DC. Okay, another symbol that you're going to see is this one right here. And that stands for ground, or earth ground. We'll explain all this, and then I'll actually show you, where they're at on equipment, and then how to connect it up in some of the upcoming videos. Another thing that you'll see that might flash up on the display or something, okay, that symbol is a fuse. So, it might come up and give you a warning that you've blown a fuse if you've hooked up your meter wrong or whatever, and forgot to move a cable, which we'll cover. before you went and switched to checking out a voltage or something, or maybe you were overloaded. Another symbol that you'll see is that one right there. And that's going to be, it doesn't look like much, but that's supposed to be a thermometer. So that's going to be, you know, if you see that, that'll be, means it's got the function to measure temperature. Then you'll see this little symbol right here. That's capacitor or capacitance. So if your meter has the ability to do that, you can check the capacitance. And you got another one, which is basically the omega symbol, which is telling you that that's for measuring ohms or resistance. And you got this one, which is just showing you that you're going to get a sound or a beep or something. And then that is a symbol for telling you that it's continuity, means that you've got a path for something to flow through or your current to flow through. And we got one more that's typical. And that's a diode. So a diode is basically just like a check valve in a water system or hydraulic system. It allows your current to flow one direction and then not the other. So that's going to be the basics of the symbols that we're dealing with today. And we'll actually go into that in a little more detail. Now, here, this kind of goes back to the safety, but this is very, very, very important. You've got ratings of your meters. And if you look right here on this meter, remember where I showed you, you know, the triangle with a little lightning bolt in it? Okay, right there. It says category 3 and category 4, and it has a voltage rating. And that voltage is telling you what its rating is for the category. So this particular meter right here is category 3, and it's rated for 1,000 volts. And it's category 4 at 600 volts. So that doesn't really tell you a whole lot unless you know what those categories mean. So category 2, which should not even be in an industrial plant, because it is only rated and tested for things like around the household, for portable tools, for just small appliances and stuff like that. So category 2, which that's like this meter right here. This is a category 2, and it does not belong in a manufacturing plant that has 480 volts and equipment and stuff. Category 3 is rated for distribution circuits, you know, such as, you know, inside of a plant. And, you know, it can go up to 600 volts, 1,000 volts, and for your different ratings, you know, each one of those. So it is designed to be used inside of a manufacturing plant or testing equipment and stuff of that nature. So that is the minimum that you want. But you can also find one of them that if it's category 3, and if it says category 3 and it's only 300 volt, then that's not going to do you any good in a plant that's got 480 volts, because 480 volts is already more than the meter can handle. Sorry about that. I had to get a break and get me a drink. Now, for the category 4, which is your highest rating category for this type of meter. Category 4 is for line voltage. It's for like overhead, for underground. It's for basically, you know, your low voltage power grid systems. And now that's, you got to really watch your ratings on that, because you don't want to get inside of, you know, any switch gear or any, you know, substations or anything else with that type but you're really not going to use these type of meters for that anyway. But that's basically what you've got to look for when you're getting a meter to work inside of a manufacturing plant. Now, as far as measurement functions, it's going to vary with all the different meters that you get. Almost all of them are going to allow you to measure AC, which is alternating current, voltage, and current. They will also go ahead and let you do DC voltage, and most of them will let you do current. Now, the next thing that most of your multimeters will do is going to be giving you continuity, and measuring ohms or resistance. And another thing that most of them are going to give you is frequency, which we'll cover that a little bit more, but frequency, which is basically just how many times it goes through a sine wave right here. Like in the United States, ours is set at 60 hertz. Over in Europe, it is 50 hertz. So that means how many times it goes from that point to that point right there per second. Cycles, that's basically what it is. It's a full 360-degree cycle. And some of the higher dollar ones will let you go ahead and then measure temperature. They'll let you measure diodes. They'll let you measure capacitance. Just to name a few. You know, it all depends on what meter that you have and what capabilities that they're offering for you and stuff. So, you know, if you're going to be doing a lot of work around air conditioners, a lot of work, you know, on single phase motors that use capacitors and everything, you definitely want a meter that has the capability to measure capacitance. So that covers your basic functions of a meter. And then we're going to actually go through all these functions on live circuits. Now, the next thing is units. Units is what this meter is going to be, or what all these meters are telling you. So you got to know what measurements that you're actually looking for. So if you got it set to volts, then obviously it's going to be measuring in volts, but it could also say MV, which that means millivolts. So, you know, that could start out, it could be a milli is like 1,000th of a volt. So that's just a minute. So you have to know that what milli actually means when you're measuring voltage. You wouldn't want to have it set to a range if it's a manual one at millivolts and then be testing something that's 100 volts. Okay, the next thing as far as units go is current is going to be measured in amperes. Her frequency is measured in hertz. And so this is what you're going to be seeing on your meter is that symbol right there, HZ. You're going to see the A for current, for volts. You're going to see the V for this one right here, for resistance. It's going to give you the symbol omega, which is telling you you're measuring ohms. And let's see here, what's another thing? Temperature depends on if you've got it set for Celsius or Fahrenheit. So you want to know that. Another thing with the hertz might have a K in front of it, which K stands for 1,000. So, if you've got a K hertz displayed, it's telling you that you're into the thousands of hertz. So if it's got 1K hertz, you're 1,000 hertz. And we'll get into capacitors. Capacitors are measured in farads, and they'll usually go from a range that you'll actually see an N, F, and then a M, F. So you're going to be looking at nano and microfarads. And there's a little symbol, if I can draw this right for you. It looks kind of like that. And that's for capacitance, which is measured in farads. So now that's got us covered as far as, most of our functions, units that we're going to be looking for, and we'll cover each of these as we're actually going out there testing live circuits, which is what we're going to be doing in our next ones. So what to expect on our next videos is video number 3, which follows this one, is voltage. We're going to be checking AC, DC. We're going to be checking it in millivolts. We're going to be checking the single phase, 3-phase, and then show you how to do all those. We're going to be in video 4, we're going to be covering current, which I'll show you how to do it with a clamp-on meter, and then what we're going to be looking for and where we find the sources to know what we're going to be looking for, versus actually sitting there measuring current with this type of multimeter, which you're going to have to break into the circuit to do that. We're going to demonstrate both of those. Ohms. So we're going to be measuring resistance, and then you need to know how and what you're looking for with the resistance. So we're going to be covering that in video 5. And that's a good one, for tracing down circuits and checking components and stuff of that nature. And then the extras. The extras are going to be things like, you take like this meter right here. It goes ahead and has a hold function. It's got an auto function. It's got a manual function. This one only has manual, so you have to know what you've got or what you're going to be testing. But this one automatically, if you set it or it already is defaulted to where it's going to go ahead and go to the right setting unless you put it in manual mode. This one also has a min-max, and it also has the capability of a different accessories that you can add to it to measure temperature, just to name a few. So we're getting ready to get into some really interesting stuff that's going to help you out in the field and make you be a lot safer and be able to be more proficient as a troubleshooter, as a tech out in the industry. So if you like this stuff, I look forward to seeing you on the next video. And we appreciate it if you go down there and then hit the subscribe button. It helps us out. And then it lets us know that, you're watching, and it will notify you of the ones that's coming up or the next time, that these videos are coming up. And we appreciate you. Have yourself a good day.